On our HTML lesson, what we have discussed last day is about the basic tags. Under that, we have discussed about these basic tags: bold, italic, underline, emphasis, headings, and superscript, subscript, how we can use that, deleted text, inserted text. And some of these we have not discussed, but mostly we have discussed almost everything last day, except a few. Maybe we have not discussed bigger text, which is bigger than the existing size, small text, which is smaller than the existing size, that we have not discussed. But other things we have already discussed. Okay, so then after that, after discussing that, we have moved to the, we need to move to the next thing, that is basically how we can use attributes, right? This also I have discussed. Attributes are used to describe the tags. So when you use an attribute, here you can see attribute has an attribute name, an attribute value, attribute name and value. Then here font color red, will apply red color to the font. That is further explaining what this tag does. And here size 6 is assigning size of 6 to face, means the type of font. So here 3 attributes are there: color red, size 6, face. And here also there are few attributes: direction of width 400, height 300, behavior alternate. These 4 attributes are there. Likewise, we can use attributes to further explain the tags. So that also we have done last day. And today, what we are going to learn is about the HTML colors. HTML colors. And in HTML colors, basically, those are also string colors, because HTML websites, these websites that we make, need to be presented in the string. So basically, there are 3 colors: red, green, and blue. So those 3 colors we are using as HTML primitive colors: red, green, and blue. And each color will get 8 bits. Each color will get 8 bits. 8 bits means 8 binary digits. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 binary digits. And you know how to convert binary to hexadecimal, right? Or do I need to explain that? Binary to hexadecimal conversion?
I don't think I know.
Okay. Okay, then let's learn about that as well. And like, okay, do you know how to represent a number in binary?
Yeah.
Okay, that's by dividing continuously by 2. Okay, 4 in binary. What is the binary value of 4?
That's 0.
0.
Wait, not 0, 1.
Sorry?
So it's just dividing by 2 continuously. So
yeah, okay, divide by 2. Okay, divide by 2. What is the remainder?
that's 2, and then divide that
And
by
2,
2.
and remainder is 0. Okay, then again 2 divided by 2, then it is 1, and remainder is still 0. And then you have to divide 1 by 2, and that is 0. And you can see the remainder is 1. Then you have to take from bottom to top, right? Bottom to top. Then the value is 100 in binary. So I hope that you can remember this method, right? Dividing by 2 and write in the remainder. Can you remember that?
Yeah, I remember that.
Okay. So in hexadecimal, basically there are 16 digits in binary. In decimal, how many digits? In decimal number system, how many digits? Yes, normal decimal number system, we do calculation in our day-to-day life. How many digits are there? Sorry?
1 maybe?
Decimal number systems. Decimal date, like how we express date is 26. Time is, sorry, date is 21. Time is 21 past 5. Likewise, how these are explained. So how many digits we are using? We are using 10 digits, right? 0, 1 to 10, 0, 1 to 9, 0, 1 to 3, 4, 5, 6, 7, 8, 9.
Okay.
We are using 10 digits. That is how we use in decimal. I think you need to write down this basically because these number systems are very useful for the calculations. Therefore, you need it.
Okay.
You need to know this. Otherwise, it's very difficult to know. Difficult to calculate the colors because you need to know how these number systems are working first. Actually, you can see in decimal number system there are 10 digits from 0 to 9. 10 digits are there in decimal. Only write the English part. Other part is not needed. In decimal number system, the base is 10, and there are 10 digits, including 0. There are 10 digits. And then when you're writing the decimal number, you have positional values. Right? What are the positional values? Like you have ones, that means 10 to the power 0. Then you have tens, right? Then you have hundreds, or 10 to the power 2, and thousands, 10 to the power 3. Here you have 7,800, 2 tens and 3. Altogether, the value is 7,823. Right? The value is generated by multiplying the position value with the digit, right? Position value 1, 3 digits, and digit value 3. 1 into 3 is 3. Position value 10, digit value 2. 2 into 10 is 20. Position value 100, digit value 8. 8 into 100 is 800. Position value 7, digit value, so position value 1000, digit value 7. 7 into 1000, 7000. Position value position value 0.1, digit value 3, so 0.3. Position value 0.01, digit value 2, 0.02. Position value 0.001, digit value 4. So the total value is 0.004. So this number can be read as 7,823.324. I hope you understood that concept, right?
Yeah, I think I do. I'm just going to write it down.
Okay, that's right. These are calculations, therefore don't take screenshot. You need to write down, right? All the position value. The most significant digit is the highest position value. The least significant digit is the smallest value. The most is basically the left. The least is in the right. Okay, in binary, you have 2. Base is 2 digits. Same thing applies. Only write this, the left-hand side, let's highlight that. Continue the same, right? This is applied for other number systems as well. So there are few more number systems. One is called octal. In octal, there are 8 digits, 0 to 7. There is a pattern, right? In decimal, base 10, no? So 0 to 9, 0 to base minus 1. 0 to base is 10, 10 minus 1 is 9, 0 to 9. Here base 2, no? 0 to 2 minus 1, it is 1. Here 0 to 8 minus 1. 0 to 8 minus 1 means it is 7. Here hexadecimal 0 to 16 minus 1, which is 15. But in order to write 15, we are not using numbers after 9, because when we use 10 here, again you are reusing 1 and 0. You are reusing 1 and 0. Here 1 and 0 you are reusing. But to avoid that, for 10, they are using A. A is 10, B is 11, 12, 13, 14, and 15. These are the values. 11 to 15, these values are there. So after 9, because each number system, if base is 8, the positional values will be 1, then the next position 8, next position 8 into 8, next position 8 into 8 into 8. Because here 1, 10, 10 into 10, 10 into 10 into 10. 1 into 10 is 10. That into 10 is 100. That into 10 is 1000. 1 into 2 is 2. 2 into 2 is 4. That into 2 is 8. Here 1 into 8 is 8. 8 into 8 is 64. That into 8 is always 8 times. Base 8 is 8 times. Base 2 is 2 times. Base 16 is 16 times. I hope you can understand that, right? So same pattern, but only thing is different digits. Based on the base, different number of digits. So please continue to write the same. For these hexadecimal also, please write down up to. Okay, you can easily convert between these number systems by like using small table. Actually, the easiest conversion is from this binary to hexa and binary to octal and also octal to hexa and hexa to octal. These conversions are easy. These conversions are easier than like other conversions. So how do we convert? First of all, we need to write down the relevant octals, relevant binary digits related to these octals. This you can do by dividing, or there is a pattern also. One thing is you can divide and do this. The other thing is there's an easy way of doing that. This is the octal table. So there are 8 digits in octal, no? 0 to 7, there are 8 digits. So 0 is anyway 0. No? We can write 3 zeros, that doesn't matter. Adding more zeros will not change the value. Then here, see the pattern. After the last digit change, it toggles 0, 1, then 0, 1, then 0, 1, and 0, 1. It toggles one after another. Then 0, 0, 1, 1, 0, 0, 1. Then it double and toggle. Then 4 zeros, 4, 1. Again, it doubles and toggle. Here 0, 1, 0, 1, 0, 1, 0, 1. 0, 0, 1, 0, 0, 1. 4 zeros, 4 ones. So this pattern, when you divide also, you'll get the same. So let's divide 7 and see the binary. 7 divided by 2 is 3, remaining 1. That divided by 2 is 1, remaining 1. 1 divided by 2 is 0, remaining 1. So it is 1, 1, 1. Ultimately, 7 is 1, 1, 1. Either from division or from this pattern, you can write. So pattern is easier than the division, right? When you write using pattern, it is easier than division. So shall we write down the octal to binary table and hexa to binary table this way? Hexa to binary also same, right? Let's see 9. Let's take 9. 9 divided by 2. It is 4, remaining 1. 4 divided by 2. It is 2, remaining 0. That divided by 2. It is 1, remaining 0. 1 divided by 2. It is 0, remaining 1. So bottom to top, it is 1, 0, 0, 1. Here also you have 1, 0, 0, 1. Same. Here, 1, 0, 0, 1. Same thing. So, but this uses pattern, right? 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Likewise, then 16 times. 0, 0, 1, 1, 0, 0, 1, 1, 16 times. 4 zeros, 4 ones, 4 zeros, 4 ones, 16 times. 8 zeros, 8 ones, 16 times. So let's write down these tables now. Did you understand the pattern first? Minal?
Yeah, I understand the pattern.
Divide in and find in the answer also, right?
Yeah.
Okay. So shall we write down both tables?
Okay.
Okay.
You have to.
This meeting is being recorded.
Let's do the conversion. Let's say you have a normal decimal number. You know you need to divide it by 2 and write the remainder. But when there is a binary number, if you want to convert that number to hexadecimal or octal, it's very, very easy. But the fall calculation I will do later. So when you have the binary, how do we convert that to hexadecimal or octal? Let's do that now. When there is a binary, how do we convert that to hexadecimal or octal? So the method is basically you can write the number. You can write the number here. When there is a binary number, you need to write that number into like 3-digit groups or 4-digit groups starting from the right corner. Starting from the right corner, you have to write either 3-digit groups or 4-digit group based on your conversion requirement. Okay, let's say the number is 1001. You need to convert this to octal. Okay, binary to octal. In the first step, what you need to do is you have to write this 3 by 3 starting from your right side. That means 001 is the first group. The next group is only 1. So in front of that, you can put zeros. That doesn't matter. These zeros are borrowed zeros, or just zeros just to fill this. You can add these zeros. And then 001 in the table is 1. 001 in the table is 1. So ultimately, this value is 8 in octal. Okay, if you are given the same task, convert the same number to hexadecimal, you write down this and then go to the table and look at the number to hexadecimal. When you are converting that, you go and see the number in the table. So 1001 is already a group of 4. So it is 9 in hexadecimal. Okay, similar to that, I will give few numbers. Now you try to convert that numbers to octal and hexadecimal. Convert to today is mathematical. Convert to octal and hexadecimal. I thought that you know this, but anyway, so let's do it. We can insert this number. Okay, let's convert these numbers to octal and hexadecimal quickly. Look at the method that I have applied. Write either 3 by 3 from the right side, not right to left, right to left. Okay, when you write like this, it's 205, correct? Then the next is 4 by 4, it should be 85. Okay. Then this one is 12Z, 3 by 3 is 1, 1, 3, 3, 1, 1. Okay, correct. Next one is FF, correct. It is when writing like this 7, 7, 377. 377, yeah, 377 is FF. And this one is 1, 7, 1, 7, 2, 5, 2, 5, 2, 7, 1, 2, 5, 2, 7, 1. In hexa, it is 9, B, yes, this is A, 2A, B9, correct, yeah. 25271, correct. This one is 14, 9, 9, 13, D should be D99, E, D99E. Yeah, see D99E, and this one is 656. Okay, so likewise, you can do the calculations. It's not difficult. Right, likewise, you can do the calculation. It's not that difficult. Okay, now you can understand it's not that difficult writing this. Okay, then let's do the color calculation part now. Now you can do the color calculation easily, because otherwise like it will be quite difficult because you don't know about the color calculations and number systems. Now let's see, each color will get each color will get 8 digits, 8 binary digits. And what you need to do is like you have to write first red, then green, then blue. First red, then green, and then blue. This is how you write the colors. First red, then green, and finally blue. Okay, when you're writing like this, so if all 8 bits related to red, all 8 bits related to red, it is 1, 2, 3, 4, 5, 6, 7, 8 is 0. 1, 2, 3, 4, 5, 6, 7, 8, green 0, and then blue also 0. So you can write 4 by 4 and hexadecimal code for the same one will be this, and it is no green, no red, no blue, so the color is black. And the second one, you have no greens again, no red, no red, no green, but there is blue. That is FF amount of blue, maximum amount of blue, it is blue color. And this one is no red, but green is there, blue is not there, so it is color green. Likewise, we can create different colors. All together, we can create 2 to the power 24, which means 16 million colors, because there are 24 bits. If there is only 1 bit, 2 colors, no, 1 and 0. If there are 2 bits, 0, 0, 0, 1, 1, 0, 1, 1, 4 colors. If there are 3 bits, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, 8 colors. So if there are like 1 bit 2, 2 bit 4, 3 bit 8, 4 bit 16, 5 bit 32, likewise. So 2 to the power that bit. If there are 24 bits, 2 to the power 24, which is 16 million colors. Likewise, you cannot write color name for each color. You cannot write color name for each color, but we can recognize some primitive colors like red, green, blue, yellow, magenta, cyan, white. So likewise, we can detect some colors, but other colors we cannot exactly tell the color value, color name, but we can tell it how it looks like. We can tell how it looks like. Okay, so now actually you need to write down this part. I know it's a little bit lengthier, but you need to quickly copy down this because it's really essential. Think and write down. Think and write. While thinking, write down. These are red bits, green bits, blue bits. Then the relevant correspondent hexadecimal and then the color name. So please write down. No need to write after that. Here, no need to write that. So actually, I will give that separately. But this part you need to write down first. Actually, after writing down, we can apply it. Let's write down first. No need to write down the binary since it is lengthier. You can just write down hexa code. Just write 1 or 2 or 3 binaries. After that, no need to write down the binary. Just write the hexa and then write the name of the color, right? So first 3 you have to write binary, hexa, and the color name. The second, after that, just write the hexa and the color. Hexa and the color, that is enough. Like this. You can go to your codes and apply your colors. So as background colors, or you can use them as some, like you can apply as background colors, or you can apply as font colors, anything, right? Let's go and see them. And in HTML, anywhere you can use this color, not only in HTML, this can be used in Photoshop and other graphic applications, anywhere, because the same theory applies. So see here, okay, I just need a small website, just page with a different background color, just creating a new one, and you can try this with me, HTML and HTML close. And then head open, head close, and body open. Oh, body close, that should be like not within the outside the body section. Title open, title close, like that. Let's create the basic page. Fellow colors. I just want to apply the background color with the color code. I can say BGCOLOR equal hash, then the number 78 red, green, let's put 99 green, and CA amount of blue. So which is highest? Is it red or green or blue? Which is largest? Is it red portion, green portion, or blue portion? The first
What do you mean?
red, second 2-digit green, so the next 2-digit blue. Which is large? Is it red or green or blue?
Oh, blue because of the
Blue.
letters.
Because of the values, blue is large. So therefore, when you save this page, you can see the color in blue. Let's say HTML, save the documents. And when you save it and open it, you can see that page in blue color. So why there is a light blue? Because you know the amounts are high. When amounts are high, it is closer to white, so it is light. So if I want to make it darker, I can reduce this amount and also reduce this amount just to make it like 60 somewhere, and 70 or some reduce it to 30. Then this will be darker than the previous. Likewise, I can control the color. You can try this. You can try different color codes, different mixtures. Let's mix some more red, and this will become purple. Likewise, you can try different mixtures, right? Different color mixtures. So let's increase the green portion, and this will be greenish now. So likewise, you can change the colors and color digits and get different values. That is possible. You can get change the color digits and get different values. So that is possible. Okay, just give a try. You can just code and see, change the values and see. With that, I will stop for today. You can practice colors, apply colors to fonts and different things and see how it changes. Okay. Okay, then. Okay, goodbye.